Today we're going to look at redox reactions and the ionic half equations that go with them. Now, electrochemistry is concerned with the transfer of electrons, like we've seen in the previous video, where electrons are transferred from the electrodes to the ions themselves. So this is why the definition of oxidation and reduction are in terms of losing or gaining electrons and not oxygen. So we can remember oil rig. This stands for oxidation is loss of electrons and reduction is gain of electrons. Now, as the ions come into contact with the electrode, they either lose or gain electrons, and this forms neutral substances. These substances are then discharged as products at the electrodes. Now, as we can remember in electrolysis, we have an electrolyte with two electrodes placed into the electrolyte that is attached to a power source. Now, the positive end of the power source is attached to an electrode called the anode, which will be positively charged. And the negative side of the power source is attached to the cathode, and this is the negative electrode. Now, at the positive electrode, negative ions would be attracted to it, like for instance chloride. Now, when chloride comes into contact with this electrode, it will gain 2 electrons. That is because it needs 2 electrons to neutralize 2 chloride ions. This will then form chloride gas. So we can remember that negative ions will lose electrons to become neutral. Now, the cathode is negatively charged, which means that positively charged ions would be attracted to it. A good example of this is hydrogen. Now, when hydrogen comes into contact with the cathode, it will gain electrons to become neutral. Now, 2 electrons are gained because we need 2 electrons to form hydrogen gas. So at the anode, where negative ions lose electrons, oxidation takes place, and at the cathode, where ions gain electrons, reduction would take place. Now, ionic half equations only show half of what is happening in a reaction that involves electron transfer. So the ionic half equation for oxidation will show the loss of electrons, and the ionic half equation for reduction will show the gain of electrons. So let's have a look at how we can write ionic half equations. And we're going to start with our metals. Now, our metals are positive ions. These include, like for example, lithium, copper, and aluminium. Now, we can see here that lithium, copper, and aluminium have different charges. The lithium is 1 plus, copper is 2 plus, and aluminium is 3 plus. Now, all of these positive ions will gain electrons to become neutral. This means that they will be reduced. Now, these different charges on top of my metals indicate the amount of electrons that are needed to neutralize them. Now, let's look at an example. If we have lithium, lithium has a charge of 1 plus, which means I need to add 1 electron, and that would give me a neutral lithium ion. Now, copper has a charge of 2 plus, which means I need to add 2 electrons to get a neutral copper atom. And then lastly, I have aluminium. And aluminium has a charge of 3 plus. So I can add 3 electrons, and this would give me a neutral aluminium atom. Next, we have our non-metals. Now, our non-metals are typically negative ions like chloride, bromide, and hydroxide. But there's one exception to this rule, and that's hydrogen, which has a positive charge. Let's have a look at a few examples. So the first example that we're going to have a look at is hydrogen. Now remember, hydrogen is diatomic, meaning that it will always be bonded to itself if it's not bonded to another atom. Now in this ionic half equation, we would need two positively charged hydrogen ions. These two positively charged hydrogen ions will then receive two electrons, which will then form neutral hydrogen gas. So we can see 2H positive plus 2 electrons gives me H2 gas. Now because hydrogen is receiving electrons or gaining electrons, it is reduced. Now the second example that we're going to do is a negative ion, and these ions are oxidized. So halogens like chloride and bromine is also diatomic, meaning that we're going to need two of them. So we're going to need two chloride ions, and this will give us two neutral chloride that lost two electrons in total. Lastly, we have our hydroxide ion, and this is also called the oxygen half equation, and this one is the most complicated of them all. So the ionic half equation of the hydroxide ion will form oxygen and water. Here, hydroxide ions, 4 of them, will lose electrons. So 4 hydroxide ions would form oxygen, which is diatomic, and 2 water molecules and 4 electrons. We can now have a look at how our half reactions would look in the electrolysis examples of the previous video. So the first one we did was molten lead to bromide. Now molten lead to bromide has the chemical equation of PbBr2. So here I have lead, or Pb, that has a charge of 2 plus, and I have bromine that has a charge of 1 minus. Now my lead would gain 2 electrons to become neutral lead, and my bromine would be 2 bromides, which would lose 2 electrons to give me bromide gas that's being released at the anode. The next example is of concentrated aqueous sodium chloride. So this would be NaCl. Now because it is concentrated, it means that my chloride would react and not oxygen. But if we look at sodium, hydrogen is less reactive than sodium. Now because sodium is more reactive than hydrogen, hydrogen would rather react at the cathode. So at our cathode we would have 2 hydrogen ions with 2 electrons being gained, giving us hydrogen gas. And at the anode we would have our 2 chloride ions that would then lose 2 electrons to give us chlorine gas. Lastly, we're going to have a look at dilute sulfuric acid. Now this is H2SO4. Now firstly, because it is dilute, oxygen and water would be produced at my anode. But because it's hydrogen at my cathode, it does not matter if hydrogen is more or less reactive than hydrogen because it's the same atom. So at my cathode, I would have 2 hydrogen ions gaining 2 electrons and producing hydrogen gas. At my anode, I have my 4 hydroxide ions producing a diatomic oxygen molecule, 2 water molecules, and 4 electrons.